Inventory cube size is extremely crucial to determine to measure the utilization of warehouse. To start with, all what you have to do is to calculate the storage area by multiplying the length and width of racks by the height of the highest load in each area. So this cubic form for each area to arrive at your inventory cube size. So let's take a brief example how it is calculated. Okay. So we do it very briefly. I'm gonna consider this example to calculate the cube size. So all the material available in the factory will be added together. So in our example we have the pipe large diameter, the metal sheet, metal cone, high thickness sheet, pipe small diameter, I-beam, dot stock, H-beam, U-channels, and angles. So we got those values, and when you add them together they will sum up to 2450 cubic meter. So let's see here another example related to measure the utilization of the warehouse. Saying if we have a warehouse that is 300 meter wide and 200 meter long warehouse with 5,000 square meter of office space, so we have literally 55,000 square meter unusable space, okay, in the warehouse. Not unusable, sorry, it's usable, like dedicated for the warehouse. Okay, once you multiply this number by the clear height to find the storage capacity, if we have a height of 27 meters, which is extremely high, so this will come up to 1,485,000 cubic meter. Since the number are not very reasonable, so they will come up to 1,485. So all what I have to do is multiply the length times the width times the height in order to calculate the total inventory cube size, how much you've got in this factory. Okay, this number is a 1,485. we put it on the side, and then we calculate all the storage capacity. We add all the volume of all the product we have stored in the warehouse, which are 225,000. So once we divide this 225,000 by the total volume capacity of the warehouse, we obtain the warehouse utilization. So I will repeat, all I have to do is to divide to calculate the total warehouse capacity, which is the height times the width times the length. Okay, and you put this as the denominator, and the numerator you add up all the products volume, you add them together and you put them in the numerator. Once you divide this value divided by the denominator, you get the percentage utilization of the warehouse. Okay, if we consider an example just to see, as we said here, like the total capacity usage, the one we have is 2,450 cubic meter. Of all the products we have in the warehouse, they come up to this value. Okay. In the next video I'm gonna show, we're gonna consider another example, or let's do it in this video. So if we go back to the start of this video, so we have a warehouse of an area of 3,300 square meter, and we're gonna we have the width times the length is 3,300 square meter, and we're gonna subtract the area occupied by machine and offices. It will come up to 2,573 square meter. We multiply by this by the height currently used, which is 3.5. The maximum use is 3.5, so this is 9,000 cubic meter. Okay, so in this case, the one we have here, in order to 9,000, just memorize this number, which is like the width times the length times the height, which we put this in the denominator, and if we add up all the value of a product, the volume available, they will come up to 2,450. So we divide both numbers, we got 27.2%, which is the space utilization. Okay, so what we did here, this slide, we based on those recommendations, the one we have here is to divide the storage in section, clear aisle, maximize the height, store product in the way of market need. So we come up with an extra of 150 square meter on top of, sorry, I'm never gonna get this properly, on top of all those values. So those values are the warehouse area minus machines and the offices. So we add to it 150, which is like the newly found emptied space. So this is 2,724 square meter. We multiply this by the height, okay, which is we maximize the storage going upward. So this is like cubic meter, okay, an inventory cubic size. So when we have a new space for the product, so we could store more products, so this will come up to 150 square meter. Okay, so we divide the value divided by the capacity of the warehouse. We obtained the new percentage of utilization of the warehouse. Okay, so in brief, what I'm gonna say, just to summarize it, so you go into a warehouse, you measure the length times the width, okay, you measure the length times the width times the height of the warehouse, which is the maximum or the highest point of storage in the warehouse. So this will be the warehouse. You put this number in the denominator as capacity, and then you add up all the capacity of all the products available in the warehouse, and you put them all together as a summation. You put them as a numerator, and you divide both values to get a ratio. So any modification you could obtain in order to maximize both values, like you maximize the storage of product, you increase the number of products stored, as well as you increase the number of height in the warehouse available. So this would lead to a higher ratio in the warehouse, okay, and better utilization of the warehouse. So if you have any question, write to my email address. Thank you.